I'm inspired to talk to you today about this. I've got a coaching client who's asked to learn about Agile. Of course, he knows a lot about project management and he knows about software testing and engineering. And I love the way he articulated to me that what he wanted to do was add some tools to his toolbox. And those tools would be agile tools that helped him know how to build things when he didn't know what the end result was going to be. And so we started to talk around what sort of examples have you got of, when you wouldn't know what the end result would look like, and why is that important? And he said, well, if I was going to build a house, I know exactly what a house is going to look like. I can draw up the plans and I can start from that, which is the end, and work backwards. And I can build my plan. I can use Microsoft Project or whatever it is. I know all the steps. And he said, and there are certain things that I don't know what the end result is going to be. I know what it needs to achieve because I've got aspirations. And he said, for instance, staff engagement. I want really good staff engagement during the lockdown, but I don't know actually what that would look like. Or I might want to take a manufacturing process that we have and improve it. And again, I don't know what that improvement is going to look like. So I can't really work backwards from it. So this made me think of a couple of things, one of which is this. This is actually a document from 1753, self-published by a gentleman you might have heard of named Thomas Chippendale. And he became very famous for these designs. Now, for him, these furniture designs were just what he thought was the aesthetics of the time, the Gothic Chinese and what he called the modern taste. But because he published them in his directory or director, they'd become associated with his name. And of course, it's Thomas Chippendale, so this is known as the Chippendale style. But in fact, what he was offering is variations on what the end result would look like. And if you look at these three Chinese Chippendale chairs, you'll see that we've got different levels of detail on the left-hand side leg, and this is a plain leg, and then similarly on the backs they've got different embellishments. The runners, here's some carvings. One of them's got an arm, and it goes through this throughout the director. Really, they're different samples. So this is very much the what. So I quite like this idea of why, what, and how. So this is the what. You're designing a chair in this style. But in fact, before he gets to these, because remember, Chippendale was a cabinet maker, what he does is tell you how to design or how to build a chair. He's giving us the pattern for a chair. And in the director, there's many different types, different styles of chairs. But it's all preceded by this, which is the rules for how to draw a chair in perspective. And of course, it doesn't matter what type of chair you're drawing. These are the rules. And it really matters if you're an 18th century cabinet maker and you're making chairs for people. It matters that they're the right proportion and the right height and so on. So he actually gives you this how. So we've got the what, which is what style would you like? And then we've got the how to build it. And I thought this really tied up very nicely with my coaching client, is what are the right tools that I need? And of course, very obviously here, the tool will be, you need to be able to draw a chair in perspective. And then you need to decide what sort of chair it's going to be. And then we moved on to not everything is visible or plannable up front. Some of it only emerges as the situation or as information develops. So sometimes we really can't say what the end result is and work backwards. And for that, the model that came to me is known as Cynefin, the Cynefin framework. Now, how are we going to connect 18th century Thomas Chippendale, cabinet maker, making chairs, with the Cynefin model, and then onto non-deterministic things like making improvements in software processing or engineering. So when Chippendale set out to make chairs, or make a chair that would appeal to discerning customers, he was solving really the simplest of problem, which was people want somewhere or something to sit on, but also they want it to look good. So Chippendale came from Yorkshire, where it was very common for cabinet makers to just make the same chair that they were taught to make as an apprentice, probably by their father. And they would just go on making that chair, which is why we have regional styles. And what Chippendale did, and he was a leader in this, is he moved to London and he collected the various styles of the day. And he said, I think all of these styles are good. They're all modern taste. They would appeal to the gentleman of today who will be ordering chairs. And therefore, the problem that I'm solving is a chair that's correctly proportioned, that fits the job of somewhere to sit, but also looks good enough for somebody in society to sit on. And in this model, as a leader's framework for decision making, in the Cynefin model, he was solving a simple problem. And in fact, or he was solving an obvious problem, which is something to sit on. But he then upped the game, and he moved round into the complicated, because if you look at the designs, some of those designs themselves are complicated. However, he solved that by saying, here is the plan for a more complicated chair, with intricate carving. So, simple chair, fine. A complicated chair, you went to Chippendale and his patterns. And of course, this idea of patterns is a repeating theme in architecture, not just buildings, but also in software and design. We follow patterns, and patterns really give us ready-made solutions that we might be able to apply to problems of the similar type. So what type of problem is it? We can choose a solution from that. This is very relevant for Agile, because there are many things that we do in an organization that are entirely appropriate for plan-driven procedural solutions. And in this model, those are called ordered. So the bottom right domain is the ordered domain. So anything that's either simple or complicated. Now, let me explain the difference between those two. If there's a task that is very, very simple, I'm feeling a little dehydrated, so I have a sense that I might need a drink, and the simple solution to that is go get a glass of water and quench your thirst. So if you see in this version of the model, we sense what's going on, we categorize it into one of a number of known problems, and then we respond with the right solution. In some ways, this is the idea of recognizing patterns, which humans are very, very good at, and finding the appropriate solution to that pattern. Now, sometime after the article was published, Dave changed the name of this domain from simple, because that really refers to the solution, and he brought it back into the problems space, and it's obvious. The problem itself is obvious. So anytime you're dealing with something that is obvious in the organization, then it probably fits into this domain. Let's give you an example. Expenses. So every month, I'm sure there's somebody in your organization that takes all of the expenses from the various claims mechanisms and claims programs and spreadsheets and moves the data into some central application. Then the expenses are probably individually approved or not, and then they're sent over to accounting for payment. So that is a procedure that can be proceduralized. We can improve that procedure and make sure that it's absolutely robust and it's going to work for 90% of the times. And having got it to that point, it's almost foolproof. It's a really solid process. And there's no reason why we shouldn't at that point send this as a task to the lowest wage mechanism that we've got, which is a machine. So we can robotize, if that's a word. We can employ robotic process automation for anything that's in that obvious or simple domain. Now, sometimes it's not worth the cost of converting it. Sometimes as well, we're not comfortable enough that we really understand the process. But when we do, very often RPA is going to be the right way to do that. And that, of course, reduces the cost of operating that and gives us a lot of scale as well. So that's the first domain. That's the easiest domain. The next domain is the complicated one, and I always talk about my wristwatch for that. So I wear a mechanical wristwatch, and it behaves as a complicated machine does. It will do the same thing all the time, really. Even when it starts to require attention, maybe the oils in there have thickened and the friction's increasing, the viscosity of the oil is increasing, and the watch slows down. That's predictable. It shows that it needs a repair, and indeed it'll go to the watchmaker, who'll take it apart, 372 different pieces. I made that number up, and because they are an expert in their field, they will know how to reassemble that and adjust it. They may or may not have a blueprint or some specification. So typical in the complicated domain is expertise required, and very often blueprints or plans. And the great thing about having a detailed plan for the solution, remember the watch itself represents the solution, is that if you know what the solution is, you can now build machinery that actually creates the watch. So you can invest capital investment in machinery that's going to build many hundreds of thousands of units. And of course, then it's just an accounting calculation to decide how many units do you think you're going to build to sell over what time, and is it worth making that investment? So that's very much the ordered, complicated world. And of course, that should be giving you all sorts of associations with the machine model that we're so familiar with. This is where the wealth of nations has been generated over the last 200 years, really the industrial machine age. From complicated, we move into the complex domain. Now, I know a lot of us use the word complex when we really mean complicated. So let's just sort out the difference. Something that's complex does not always behave in the same way. So I told you about the machine that I can build to produce lots of watches that are the same. Complexity doesn't work like that, because complexity, each thing that we would produce will be different. And the obvious example here would be an artwork or a musical composition. But so is anything to do with research. We're really investigating the unknown. And that's why the first verb that we've got here, the first action, is to probe. Let's have a go. Let's find out what's going on. And a very good word here is experiment. So we've got an idea, we've got a hypothesis, we think it's going to be possible to produce an engine that can run, for 500 miles between charging or fuel or refueling. That's a hypothesis. We design some experiments to help us probe into that unknown space. And as we're doing so, we get a sense of whether that is viable or not. Based on that information that we get back, we would respond. We may further the research. We may double down on the research and get another team going to do it as well, because we think that 2 lots of people doing it increases the chance of one of those innovations working. And this is very often the domain of software development as well, because when we're building software, we are building something that has never been built before. Now, Similar things have been built before by similar groups of people for similar customer bases. But if you're writing software, you are literally the author, you are the creator of the code, of the instruction, of the plan that is going to do something in an entirely new situation. So there's a lot of complexity in there. The other thing to bear in mind with software is very often written to a specification, whether it's a formal functional specification document or based on a conversation, or Agile people like to use stories, user stories. So it doesn't matter where that specification comes from, but that embodies the requirement as it's best understood at the time that conversation takes place. And what happens as we probe and sense and gather information is we uncover more detail. We might get some results from our experiments. So the first experiment might be based on, if I put this screen in front of the user, they will do this. And when we build a screen and put it in front of the user, actually discover they don't even notice that, and they see something else and do something else. So we'll never know that until we've run the experiment. Later on in another part of this series, I'll introduce the experiment log, and you'll actually see that we have expected results from the experiment, and then what is it that you've learned? And the two are quite different. The fourth domain is a difficult one. It's the chaotic domain. And really in the last 20 years, I suppose, there have only been a couple of occasions when businesses have really experienced it. The first was probably the financial crash 2008, and of course the current COVID-19 crisis. And what we want, what we need is action, because in a chaotic domain, there's just no information available immediately. So the only thing that can happen is for people say leadership, but actually it's for an action. So you must take an action, because the action will give you the information which you can then make sense of and decide your response. Now in action, and certainly the UK took this action, the action might be keep everybody in work, keep the economy going, keep everybody in their schools, in their jobs. That was an action. You can look at it as a do nothing, but still it was a decision to take that action. And very quickly the information came about that the rate of increase of infection was going to be so high that it would have an impact on the health service that was greater than the service could accommodate, and therefore it became necessary to choose to take new action, which was social distancing. So all of this is correct within the chaos domain, and it's moving into complex. So I always get this sense, as we look at the model, I get this sense of moving from in a clockwise motion. So we were in chaos and we moved into complex, and the social distancing was happening for a few weeks, and it seemed like we were now into a complicated, repeatable, ordered world where we believed that people social isolating for 14 days would be long enough for them to clear any infection and build immunity. And then, of course, what happened is we were thrown back into complexity as it was discovered that the virus was able to reinfect people that were already infected. Other parts of it become complicated. So where we were worried about ventilators, turns out that no, the shortage in the NHS hospitals was to do with masks, it was to do with gowns. And then it became a logistics problem of how to get those gowns through from the countries where they were being imported. And at some point that moved right into the simple domain, which is getting more people being able to do more deliveries. And therefore people went back to driving lorries, people went back to supporting the NHS, recalled into service. So we see this constant move around the domain. Now remember, these are all ways of looking at problems. This is asking yourself, what sort of problem is this? And you're doing that because only when you know the sort of problem that you've got are you going to know the right way to deal with it. If it's an ordered problem, then if it's an obvious problem, then a procedure. What is best practice to do? If it's complicated, then what is good practice? Let's get an expert. What is the right thing to do? And indeed, COVID again gives us a very good example, because the governments around the world started to look to the medics and to science to say, what do we do? But then there's complexity. And we've seen in COVID the complexity. We're into week 5 of isolation in the UK and people are getting bored. So whenever people are involved, complexity is always there, because some people are observing social distancing and isolation very strictly. Others are getting bored and going out and going into parks and socializing and difficult. Everyone understands that it's difficult. So that starts to be an unordered domain, and we don't know what will happen there. And finally, the oddly shaped little bit in the middle is disorder. And that's when you simply don't have enough information to know where you are. And that's very rarely does that last for very long before you can start to go, no, this is starting to look like a complex or a chaotic problem. So for now, this is a great place to start to leave this first introductory session and start thinking about the things that you come across every day. Where does it sit? What type of problem are you trying to solve? And I guess the best exercise to do here is keep it as a problem. Don't move into solutioneering. As engineers, we all love solutionizing or solutioneering. I know how to solve that. And you probably do. But we know that everybody's got a way of solving it. And we also know that most of those solutions will be wrong. So it's important that we understand the problem enough to make sure that we can approach it in the right way. And that's really the power of this type of framework. Other frameworks are available. So homework, read A Leader's Framework for Decision Making. It's a lovely context. Think about your work, think about the problems, the big problems and the little problems as well. And then when we come back to this, we'll refer to the model again and we'll start to see how we can use this model and break things down so that each chunk of the work that we're doing we can place in an easier or an easier to manage domain. So that's it for me. Thank you very much. Stay safe and take care.